All right, let's jump right in. Today we're going to explore a topic that's not just fascinating but also incredibly important. What happens when sound hurts, especially for people with autism spectrum disorder?
But first, I want you to just imagine something for a second. What if the clinking of silverware, the low hum of your fridge, or even the sound of someone chewing nearby, what if those sounds didn't just feel annoying, but felt like an actual physical assault, like they were overwhelming or even painful?
Well, for a whole lot of people with autism spectrum disorder, or ASD, that isn't some thought experiment. It's just daily life. You see, ASD is a really complex condition, and one of its hallmarks is a profound difference in how the world is perceived. And a huge part of that is sensory processing, especially when it comes to hearing.
Now, these intense reactions to sound aren't just a vague sensitivity. They actually have specific names, and it's worth knowing the difference. So let's break down the two main conditions we're talking about here. Both of these conditions fit under a bigger umbrella term called decreased sound tolerance disorders, or DST. It's really just a clinical way of saying that for some people, it's like the volume knob for the entire world is turned up way, way too high, and they just can't turn it down.
So what's the key difference? Well, with hyperacusis, the problem is with the physical nature of the sound itself. Think things like volume or pitch. So a loud engine or a high-pitched alarm can be physically painful. Misophonia, though, is a little different. It's this incredibly intense emotional reaction to specific sounds, often little repetitive ones like chewing or sniffing or someone tapping on a keyboard. It can trigger these feelings of real anger, disgust, or intense anxiety.
Okay, so you might be wondering, just how common is all this? Well, the numbers, they're pretty eye-opening.
So if we look at the general population, some studies show that the prevalence of hyperacusis, that general sensitivity to sound, can be as high as 17.1%. That's almost 1 in 5 people who experience this to some degree.
But now, get ready for this. A major study in 2015 by Danesh and his colleagues looked specifically at individuals with high-functioning ASD. And what they found was that a staggering 69% of them reported experiencing hyperacusis. That is a massive jump, and it really shows you just how central this sensory experience is.
And it's not just that one study. This table here kind of pulls together a bunch of different research. You can see the numbers bounce around a bit, from 18% to 37%, and then that big 69% we just talked about. But while the specific numbers vary, the trend is crystal clear and consistent. Hyperacusis is significantly more common in the ASD community. So all of this leads us to the million-dollar question. Why? What is actually happening in the body and in the brain that causes such a huge difference in how sound is experienced? Well, the science seems to be pointing to two main areas. You can think of it like a problem with both the hardware and the software. First, there might be actual physical, anatomical differences in the ear itself, the hardware. And second, there are almost certainly differences in how the brain is wired to process the sound signals it receives, the software. Okay, let's start with the physical stuff, the hardware. Researchers are looking at a few things. One is a tiny structural issue, a little opening in the inner ear. Another is something called a delayed stapedial reflex. Basically, you have this tiny muscle in your ear that's supposed to tighten up to protect you from loud noises. If that muscle is slow to react, more of that painful sound gets through. And finally, some studies show a weaker gatekeeping system for sounds, which means the ear is less effective at filtering what comes in. But you know, the ear's only half the battle. Sound isn't really heard until the brain processes it. And this is where some of the most compelling ideas are coming from. The actual neural wiring for sound just seems to be fundamentally different for many people with ASD. A key theory here is called central gain enhancement. The best way to think about it is that the brain's master volume knob is permanently stuck on high, so it just amplifies everything that comes in. There's also evidence that the auditory cortex, the brain's sound processing headquarters, might just be organized differently. It all points to the brain handling sound in a completely atypical way right from the get-go.
And, of course, you've got a genetic piece to the puzzle. Research is starting to pinpoint specific gene variants, like these ones here, that are linked to sound hypersensitivity, which tells us that these differences can literally be wired in from day one.
So the science is fascinating, right? But what does all of this actually mean for a person's life every single day? This is why it matters. The real-world impact is just profound. Take a look at this chart. It focuses on young people who have misophonia. And the areas of interference are things that so many of us take for granted. Right at the top, you've got family life, friendships, just interacting with people, learning, doing homework. You see, this isn't some minor pet peeve. It fundamentally gets in the way of a person's ability to connect with the world.
And that Danish study from 2015 gives us some really concrete examples. Over half the participants said they had trouble just reading or concentrating in a noisy room. 43% had a hard time simply following a conversation. I mean, these are essential skills for school, for work, for just having a social life, and they're directly hit by this sensory overload.
And this quote here from Jaeger and their colleagues in 2020 just hits the nail on the head. It's those emotional responses, the constant irritation, the anxiety, sometimes even the anger that gets triggered by these sounds. It can completely disrupt a person's ability to just